Hey guys, welcome back. We left off last time talking about vertebrae. We talked about C1, C2, C7, and some of their structures. In this lecture, we're going to try to go ahead and wrap up the rest of our axial skeleton. So we're going to try to get all the way down to coccyx today. And I think we'll be able to do that without too much trouble. So we left off with a thoracic vertebrae. Here we have a thoracic vertebra. The body's similar, a little bit bigger. Pedicle, same. Lamina, same. Spinous process is no longer bifid, so the end does not split into two pieces, but it does slope downward pretty significantly. And if you want, you can go ahead and check this out on our skeleton in the lab. There's a pretty steep downward slope. Our transverse processes get a little bit bigger here, and they lose their foramina that they had in the cervical vertebrae. Now there's a couple structures here that are cool, but I don't think they're on your terms to know list. I want to check this for me. There's a couple of facets, and they end up giving them some odd names. For example, as opposed to transverse costal facet, this describes it as the facet that articulates with the rib tubercle. I certainly don't want you writing that on your test. I think transverse costal facet might be a better option there. But there are a couple facets, and it's very cool to see this is where your ribs actually attach to these vertebrae. So I told you there'd be little clues that would tell you whether the vertebra you were looking at was cervical, thoracic, or lumbar. This is one of those examples. A little bit bigger body, a facet for a rib head, a facet for a rib tubercle, and so your rib is actually going to curve back a little and then head around towards the front of your body where your heart and your guts are, And so these are a couple of landmarks that'll really let you know what kind of rib you're looking at. So, spinous process, got it. The rib tubercle articulation site, got it. And the rib head, got it. So as we move down from T3 on down through the rest of our thoracic and lumbar vertebrae, the body of the vertebra are going to increase in size. And they do this because as you increase down the spine, this fellow right here is bearing more and more and more weight. And so you have to give him a bigger body to support that weight. All right. And so here we're going to look at our lumbar vertebrae. And here we have a 1, 2, 3, 4, 5, ending at the sacrum, big old cartilaginous pads. And here we have the bodies become much larger because they're supporting a lot of weight. Their spinous processes become pretty short and pretty thick. The transverse processes become pretty short as well because they're not, and we're still attaching muscles and tendons to them, but we're not attaching ribs anymore, so they're rather short because of that. And then we also get this really cool diagram of our intervertebral discs. If you ever heard somebody say that they've slipped a disc, this is what they're referring to. And what you get is this purple in this diagram is what's called the annulus. And the annulus is really tough, shock-absorbing fibrocartilage. Really tough stuff. Now this central mass performs a bit more of the cushion function. And we call this the nucleus. Not surprising, right? The thing in the middle is called the nucleus. Anyways, with age, this covering can thin, and that central mass will lose the firmness, and you're not quite as good at absorbing shock as you used to be. But this is cushioned for soft movement. And in the slip disc, if enough stress is placed on this vertebrae from, lifting something very heavy or perhaps a car accident, you can actually push a little piece of this soft nucleus outside of that annulus. And you can think not really a jelly-filled donut, but almost a jelly-filled donut. The soft center gets pushed to the outside, and then you have a slip disc. And so that's one example of a neat application to your understanding of lumbar vertebrae. So then we end with the sacrum. I really only have one problem with the sacrum, and that is that they give the same hole two different names. And I'm not really sure why they do that, and I find it a little frustrating, but they do. Here's your sacrum. It should be 1, 2, 3, 4, 5 fused vertebrae. You can kind of imagine that perhaps these are very similar to our transverse processes, and they have become fused to make this one hard bony structure. And then down here is this little teeny tiny coccyx, which should be four. 1, 2, 3, 4. 4 teeny tiny fused vertebrae. Now, there's a few terms you need to know for your terms to know list on the sacrum, so please have that out. I don't think we do body of the vertebrae necessarily, but I'm almost certain that we do sacral canal and a sacral hiatus. And so the sacral canal would be where your spinal cord nerves are running down through the sacrum, and then the sacral hiatus is the opening of that sacral canal on the lower end. I should say inferior end. We're in anatomy. So here's my problem with the naming of the sacrum holes. And I'm sure there's a great reason for this. I'm just not aware of it. This is the anterior view of the sacrum, so the front. These holes, we call them pelvic foramina, which I'm fine with, right? Pelvis is like the hip region, foramina, lots of little windows, so okay, pelvic holes. I'm cool with that. Passageway for nerves and blood, I get that. Now, if we look at the back of the sacrum, we call them dorsal sacral foramina. Dorsal, back, sacrum, little holes. so I'm looking at this and it's like, well, this is the same hole here and here. I mean, I don't name my front door something different when I walk out of it as opposed to when I come home. But I guess, I'm sure there's a good reason, and maybe you can check it out and tell me why we chose that. But there you have it. Dorsal sacral foramina, back of the sacrum. Pelvic foramina, front of the sacrum. So there you have it. And then at long last we have this little teeny tiny coccyx, which is our tailbone. And as far as like a really cool function, I'm not entirely sure, except for you can break it when you go, ice skating or skateboarding or something like that. So let's take a look at our thoracic cage. Our ribs, very important. They're protecting things like heart, lungs, kidneys, stuff you want to have. Your thoracic cage consists of ribs, 12 pair of ribs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. The sternum, which we will separate into 3 bones here in just a minute, and then our costal cartilage, which is what attaches our ribs to our sternum, and I guess to other ribs as well. So, why do you have ribs? Of course, function support the pectoral girdle, which means where your arms attach, protect the viscera, protect your guts, and they of course play a very, very important role in breathing. These actually rise and fall, rise and fall as you breathe, and so that's very important. So here's how we break these ribs down. We say we've got 7 true and 5 false. 7 true ribs go 1, 2, 3, 4, 5, 6, 7. Okay. Each of these 7 have their own direct line of cartilage straight to the sternum. Uninterrupted line of cartilage straight to the sternum. Now the bottom 5 false ribs, we go 1, 2, 3, 4, 5. And they are either floating, like the bottom 2, or they have to hook their cartilage to somebody else's cartilage so that they are indirectly supported by the sternum. It still links up to that sternum eventually, but we have to go through somebody else. And so that gives us the true and the false ribs. Vertebrochondral for the 3 that are attached with cartilage, chondro, cartilage, and then floating are these 2 little guys down by your kidney. And they're really not supported by anything. Well, of course, muscles. I mean, they're not just floating in there by magic, but as far as cartilage, they really are just floating in there. So that's kind of cool. So let's take a look at the sternum. This guy is right here, just right over your heart, between your pectoralis major muscles. That's your sternum. Your sternum is made of 3 bones. This is the manubrium. I like that because it's sort of shaped like an M. This is the body. And this little fellow down here, that's shaped like a thumb, is a teeny tiny knob called the xiphoid process. So it's located in the middle of your chest, of course. It is a flat bone with red marrow in it. There's the manubrium. It has a facet for attaching your clavicle, which you probably call your collarbone at this point in your life, but you can go ahead and change that to clavicle now. Your clavicle attaches there, and you can actually feel that. If you feel where your collarbone, your clavicle, comes around and articulates with the bone in the middle of your chest, you can feel where your clavicle ends, because for most of us, there's certainly not much muscle over our clavicle. So you can actually feel that. That's kind of cool. The body is just the long portion of the sternum that covers your heart, essentially. And then this one, fun to say, fun to spell, xiphoid process with an X. There's that little teeny tiny thumb-like thing on the bottom. And so here's your ribs. With ribs, you don't really have to be able to label like individual structures on them, but your rib is basically a long, slender bone that curves around and slopes a little bit downward from your vertebrae to the front of your body. The head of the rib articulates with a facet on the vertebrae, and the tubercle, which is this little guy right here, is going to articulate with the facet on a transverse process. And so they're connected in two places. You've ever heard of somebody who's got a rib head out? That is, this portion right here has pulled away just a little bit from those vertebrae, and it's very painful to cough, to breathe, that kind of stuff. And so anytime you see tubercle, because you will see more, tubercle means a small knob-like process. And so it can get a little bit confusing when we get to processes, tubercles, and trochanters because they all mean almost the same thing. But there you go. I guess a small knob-like process, that's a tubercle, that's a rib tubercle. So there you have it. That's a rib. Cool. So there's your vertebrae. There's your spinal column. You need to know the curvatures. You need to know the structures of the ribs, or rather the structures of the vertebrae, how to name them, how to tell about where a vertebrae belongs based on the features you see on that specific vertebra. And of course, all of the bones and structures on the face and the skull. So now would be a great time. There's a worksheet that goes with spinal curvatures. There's a worksheet that goes with labeling parts of vertebrae. Now would be a great time to do those. It'd also be a great time to review the skull labeling online games and quizzes that I've posted on your homework sheets and on Edmodo, because you could drag and drop these skull terms, and I think that would really be beneficial for you. Of course, I'm always a resource in class. You can ask me, I can quiz you over skull. I've got the app on my iPad. I've got the actual skull. We've got your diagrams. We want to practice this stuff. And so you want to know this stuff. You want to know these three bones that make up your sternum. Know what ribs are and how many there are, but we're not going to spend a lot of time naming structures on ribs. This is a worksheet that you have as well. You can practice labeling that. And this is where we're going to end, because once we get to the pectoral girdle, we are officially on the appendicular skeleton. So appendages, which is exciting and very cool. But we're going to stop with axial for today, and we'll jump into appendicular next time. So thanks for your time.